All right, if you're an installer, you have definitely been there. Getting separate heating and cooling units to actually cooperate can be a real headache. So today, we're going to master the ClimateSync Auto Mode, and you'll be able to solve that problem confidently on any job site.
Okay, so let's set the scene. It's a classic situation, right? You've got a great air conditioning system for cooling, and you've got this powerful hydronic system. Maybe it's radiators, maybe it's underfloor, for heat. The big question is, how do you get them to coordinate automatically without fighting each other or making the space uncomfortable? Well, that is exactly the problem ClimateSync Auto Mode was built to solve.
We're going to keep this fast and super practical. First, we'll hit the most important choice you have to make. Then, we'll walk through the actual setup, and after that, we'll break down the system's logic so you know exactly what it's thinking and why. Let's get right into it.
Okay, first things first. Before you even think about touching a setting, you've got to understand the fundamental choice you're making here. Honestly, getting this part right is the foundation for the entire job, and I've seen it trip people up before.
This right here is the fundamental choice. Over on the left, you've got your standard AC auto mode. That's where the AC unit itself is in charge of both its own heating and cooling. Simple, right? But on the right, that's where the magic happens. That's ClimateSync Auto Mode. The controller takes charge and it intelligently switches between your AC for cooling and your separate hydronic system for heating. So for any kind of hybrid setup, this is the one you need, period.
So now, let's get our hands dirty. Once you've decided, yep, I need ClimateSync Auto Mode, getting it running is a really straightforward two-part process. It's just a quick hardware change and then some simple software configuration.
On the hardware side, it seriously could not be simpler. All you have to do is find dip switch SWC1 on the controller board and just flick it to the on position. Now, and this is the most important part, don't forget this. After you flick that switch, you have to restart the controller. A simple power cycle does the trick. That's what makes the system recognize the change.
Okay, after that restart, it's time to plug in your PC. Fire up the configuration tool and just click on any zone tab. Because you enabled that dip switch, you're going to see a brand new section pop up, ClimateSync Auto Mode. This is your new command center for fine-tuning how the system behaves.
So inside this new section, you're going to find these key parameters. You've got the overall on-off state, and then you've got these three really critical settings: the delta T for cooling, the delta T for heating, and the initial heating judgment. Now don't worry, we are about to break down exactly what each one of these does.
Now for the really cool part, how does this thing actually think? Let's look at what happens the instant a zone goes into auto mode. How does it make that very first decision, without any user input at all?
It's a great question, isn't it? The system can't just sit there and wait for the temperature to drift way off. It has to make an immediate, smart decision to either start cooling, start heating, or just hold tight and wait. And this whole process is called the initial judgment.
The logic for cooling is super direct. If the room is already warm, we're talking 1 degree Celsius or more above your set point, the system doesn't even hesitate. It immediately jumps into cooling mode to start bringing that temperature back down.
And the heating judgment is just as smart. If the room temperature has already dropped below that heating on threshold, that little buffer you configure called the hysteresis, it'll kick right into heating mode. And that last parameter we saw, the judgment to heat, that just lets you fine-tune exactly how far below that threshold it needs to be before it starts.
So what if the temperature is in that comfy middle ground? Not hot enough to need cooling, but not cold enough to need heating. Well, the system just stays idle. It's smart enough to know when to do nothing. It'll just wait patiently until the room temperature crosses one of those two thresholds before it takes any action.
Okay, so the system made its first choice. It's running in either heating or cooling. But what happens when the conditions change? The sun comes out, a bunch of people walk into the room. How does it switch from one mode to the other? This is where that changeover deadband comes into play. So those delta T parameters we saw earlier are absolutely crucial. The best way to think of them is as a buffer, or a deadband, right around your set point. The temperature has to change by a pretty significant amount to cross this deadband. And this is brilliant, because it stops the system from constantly flipping back and forth between heating and cooling, which, as you know, saves a ton of energy and prevents wear and tear.
Let's look at a real-world example of how this works. Let's say your set point is a comfortable 23 degrees, and you set your delta T to 3 degrees. If the system is currently heating, it's going to stay in heating mode until the room gets all the way up to a toasty 26 degrees before it even considers switching to cooling. On the flip side, if it's cooling, it won't switch back to heating until the room drops way down to 20 degrees. See? This creates a really stable and comfortable environment. All right, we've covered how the system starts and how it switches modes. So now for the final piece of the puzzle. Once it's locked into either heating or cooling, what is actually controlling the moment-to-moment on and off cycles?
And here's a really key detail that a lot of people miss. Once the system has committed to a mode, let's say cooling, it completely ignores the other delta T parameter. The deadband's job is over for now. The system's logic now shifts to a totally different set of rules for its day-to-day operation.
And here are those new rules. Basically, control gets handed off to the experts. When you're in cooling mode, the AC unit's own internal logic, its own hysteresis takes over. It knows best how to cycle its compressor. And when you're in heating mode, our ClimateSync controller uses its heating hysteresis settings to manage the hydronic system. It's really the perfect division of labor.
Whew, okay. We have covered a lot of ground here, from dip switches to deadbands and hysteresis. So let's pull it all together into one clear, simple framework that you can take with you to every single job site.
It really just boils down to these 3 simple stages. Stage 1, the initial judgment, makes that quick decision right at startup. Stage 2, the delta T deadband, handles the big picture switching between heating and cooling. And stage 3, once a mode is locked in, the specific system's hysteresis takes over for the fine-tuned on-off cycling. Judgment, switching, operation. That's all it is.
And that really is the goal, isn't it? When you get this core logic, you're not just following a manual anymore. You are in complete control. You can diagnose issues, you can optimize for performance, and you can set up a system perfectly for whatever your client needs.
So, I'll leave you with this thought. Now that you're armed with this knowledge, think about your next project. How wide are you going to set that deadband? A wider band might save a bit more energy, but a narrower one could provide tighter, more responsive comfort. The power to make that perfect choice for your customer is now in your hands.